Good morning, children. It's your old pal, Mr. E, here with adding and subtracting polynomials for you today. Let's get right to it. So, what is a polynomial? You can't add and subtract them if you don't know what they are. Well, a polynomial is an expression. Let's zoom in here just a second. Get darker color. An expression, with many terms. Now remember, terms are separated by either a plus or a minus. So here's an example. A term could be like x. Or maybe here's another term, 2x. Or here's another term, 3xy squared, something like that. These are all terms. I'll circle. Here's one term, here's another term, here's another term. They're separated by plus or minuses. So let's go back to this. How do you add and subtract polynomials? Well, you eliminate parentheses by distribution, just like you've done in the past. You see parentheses, you distribute what's on the outside to the stuff that's in the inside, and then you combine like terms. This is really all we're doing today, combining like terms. You can eliminate zero pairs, and I'll show you exactly what that means, and combine variables of the same degree. And that's the exponent. So let's do this exponent. All right. Then we're going to rewrite it in what we call standard form by listing everything in descending degree. So you start with the highest degree and you go down. So here's what we mean. Let's simplify some of these. So we're going to add these two polynomials. Here's one. This is actually a trinomial because there's three terms. And I'm including the plus and minus in this now because I really should. Okay, so we're going to add these together. Well, luckily these are in a nice, neat column for us. Here I've got an x squared and another x squared. So these are like terms, like terms. Here's one. Here's another like term. These x's are right here, like terms. And then the last bit, come on now. Here and here. Whoa, what? Okay, well, my screen is off for some reason. I don't know. Okay. Anyway, let's do this. Okay, so we're going to add this. 2x squared plus an x squared. That's 3. Okay, this is really weird. This is writing in the wrong place. 3x squared. There it goes. Okay, 3x minus 5x. Well, 3 minus 5 is a negative 2. So there's negative 2x. And then 2 minus 5, that's a minus 3. So there we go. There's my simplification of those. And here we go. We've got another one over here. Now look at this. This has a negative sign in the front, which means we need to change all the signs of this. So I'm going to rewrite this over here. The top doesn't change. It's all positive. Except for that last term, which is negative. But the parentheses, there's no negative sign outside the parentheses. So here's that. And this, now, since we have a negative sign on the outside, we have to distribute that negative sign to each one of these terms. I can show you better this way. Go there, and there, and there. Oh, come on. Why? Okay. All right. Well, now it's working. Okay. So we're going to distribute those. Okay, so from here, nope. A negative to the x squared, a negative to the 4x, and a negative to the 1. So that makes it negative x squared. Negative times a negative is a positive 4x. And then a negative times a plus 1 is a negative 1. So now I can add these up. 2x squared minus x squared leaves me just 1x squared. 1x plus 4x is 5x. And the minus 4 and a minus 1 is a minus 5. So there is that. Now, this is how you'll see it usually. You'll have a couple of, or you'll have just a long line of terms. And it looks crazy, doesn't it? Well, it's not crazy because, look, let's match up everything. We'll use shapes and colors. Here we go. This term right here is 4x squared y squared. So I'm going to look for these bits here. X squared and y squared. That doesn't have it. Whoops. This has an xy squared, but not an x squared y squared, so that's not the same. This one is, though. This is a 6x squared y squared. So here's another one. This has an xy. That's not right. Xy squared. Okay, so there's that. Now, I change colors. And here, I'm going to include the sign. Here's an xy term. This has an x and a y. So I'm going to look for that. That's the xy squared, but here's an xy. Right there, and then there's the xy term. And then the last bit, here I'll use red, this right here, and this right here, the xy squared terms. Okay, so I've got 3 different types. So now I'm going to add the purples together. 4x squared y squared plus 6x squared y squared. Well, that's just 10x squared y squareds. Right? Okay, and now I'm going to do the greens. You don't have to write it out like this, but I'm just doing it so you see. This is the xy term, so 5xy's plus 8xy's equals 13xy's. And then the red, let's see, that's a minus 3xy squared plus 3xy squared. And you might have seen that already. These cancel. Minus 3 plus 3, that's 0. So all of this, we can go over here and we'll rewrite it in orange. We're just going to write these pieces. That's all we have left. So 10x squared y squared plus 13xy. That is what we get right there. All right. Now, the next one, you might need to check yourself, because here we have this, a negative sign. Now, if you see a negative sign outside of parentheses, you need to distribute it to everything that's inside the parentheses right there. So let's rewrite this. I'm going to rewrite the first bit. And we can take these parentheses away because there's nothing in front of it, so we really don't need those. And I'm going to take these away after I distribute over here. So let's write all this together. So I've got 11m squared plus 2m minus 11. And then I've got this, a minus 5m squared. And then that, a negative times a negative is a plus 6m. And then a negative times a negative 17 is a plus 17. Okay, now, give myself a little bit of room. Now I can zoom in a little bit. I'm going to combine the like terms now. So here is an m squared, and here is an m squared, and that's all the m squareds. And then here is an m, here's an m, those are all the m's, and then here's a constant, a minus 11 and a plus 17. So let's add all these together, shall we? These two, 11 minus 5 is 6. That's it for the m squared, so I'm going to cross those out. I'm done with those. And then 2m plus 6m is 8m. Done with the m's. And then minus 11 plus 17. So that's 17 minus 11. That is a plus 6. So here is my final answer. 6m squared plus 8m plus 6. All right. I'm going to leave these last two for you to do on your own. And let's take a look at these. The rest of these, you can do on your own as well. Just remember, well, actually, you know what? Let's do one that has some distribution. Okay, let's do this one. It has a fraction. I'll help you through it. All right. Well, we see this term here is by itself. So I'm just going to rewrite it. 9q squared. This is what we need to take care of right here. Switch colors. This right here is what we need to take care of. Oh, but looky here. This is also a q squared. Go back to purple. This is a q squared. So let's add those two together. 9 squared, or 9q squared plus 5q squared equals 14q squared. So now all we have to do is take care of this part here with the blue. So I'll rewrite it up here. We'll give ourselves a little bit of room. What is that? 3 minus 2/3 times the quantity 3q minus 7. Okay, so we're going to distribute this 2/3 to that and to that. So 2/3 times 3, well, these just cancel. So that gives us a minus 2q. And then we need minus 2/3 times a minus 7. So we just multiply the tops. So minus 2 times minus 7, that's a positive 14 thirds. So there's that. That's simplified. So now I just need to add this minus 2q plus 14 thirds to that. And that's the answer right there. 14q squared minus 2q plus 14 thirds. Okay. Now, I'll get you started on this last bit, perimeter. Remember, this just means add up all the sides. So, don't forget these sides. Even though we don't have an expression here, remember, this is a rectangle, so these two are the same. And also these two are the same. So this is an n squared over here. This is an n squared plus 5n plus 1 over here. So just add up all these. There's a couple of ways you can do this. There's 2 n squareds, right? So you can say 2 times the n squareds plus, and there's 2 of these, 2 times the n squared plus 5n plus 1. So you can distribute that 2 and that 2 to those. That's one way to do it. Or you can just write everything out. I can start here, n squared plus this, n squared plus 5n plus 1, plus another n squared plus another one of these, n squared plus 5n plus 1. That's long, but you can, circle all the n squareds. There's 4 n squareds, and then you can put a square around the 5 n's. A couple of those, and maybe a triangle around the constants. There you go. Okay, same thing here. Just add these 3 polynomials up. That's it for me for today. Enjoy. See you next time.